All right, continuing now, so we can finish up these last two examples. First, I want to point out on this last example, your answer is plus and minus 1, which is these two roots here. That only happened because one of our roots was 1, and then we did some math and found that the other root is negative 1. So it's not always positive and negative of that number. So if I would have gotten 2 to be a root, it does not mean negative 2 is also a root, which you'll see in these next couple of examples. So first, we need to list out all of our possible rational roots. So this is a nice example because this is 1 and then 14. So we have 1, 2, 7, 14. It's really nice when either of your numbers is 1 because it makes it a lot fewer options, because now it's just everything divided by 1. So the possible rational roots are plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. So remember, we are going to start in just taking our function. I'm going to plug in a positive 1 to the third, plus 5, plugging in a positive 1 to the second, plus 13, plugging in a positive 1, plus 14. I do not get 0. I'm looking for 0 because I'm looking for the zeros. Roots, zeros, same thing. So then I can continue and I could plug in negative 1. That was supposed to be a 14, but even if it was, I would not get 0. I need 13 more. That's not 0. So, sorry I typed in the wrong thing, but even if I typed in the right thing, I would have typed in a 14. So since I only typed in a 1, if I add 13 to this, still not 0. So negative 1 doesn't work. Let's move on to 2, which you can do positive or negative first, doesn't matter. You don't even have to go in this order. I just go in this order so that I make sure that I get all of them that I'm supposed to until I get to the end. Also doesn't work, so now I'm going to try negative 2. And I get 0. Okay, so negative 2 is one of my roots. So I'm going to do synthetic division with negative 2 inside my box. So I'm going to take my coefficient as 1, 5, 13, 14. Do remember you have to have all of your terms. I have them since I have a cube, squared, a constant, coefficient, one more time, exponent of 1, and a constant. So I wasn't missing any. Like back here, I only had a 4 and a 2 and nothing. So I was missing the 3 and the 1. So that's why I had 0 and 0 there. Synthetic division says bring down your 1. Negative 2 times 1 is negative 2. 5 minus 2 is 3. Negative 2 times 3 is negative 6. 13 minus 6 is 7. And negative 2 times 7 is negative 14. Those will cancel out. Which, remember, is what is supposed to happen, because if that is a root, you are not supposed to have a remainder. This is now x squared, because it was x to the third, plus 3x plus 7. Now that you have a quadratic, you can attempt to factor. You also could complete the square or use your quadratic formula, but I will point out that since we're looking for the rational roots, if there are any more rational roots, you should be able to factor. So if you want to use quadratic formula or completing the square because you were better at that, that's fine. Just keeping in mind that I don't want any unsquare rootable numbers or any imaginary numbers. So if you do completing the square or quadratic formula and you get the square root of negative something, stop, you're done, finish with the problem. If you get something that is square root of some number that's not a perfect square, like square root of 5, square root of 15, square root of 11, then once again, stop, because there are no more rational roots. So I'm going to factor this. 1 times 7 is 7. I'm looking for two numbers that multiply to be 7 and add to be 3. The only numbers that multiply to be 7 are 1 and 7. I need to multiply to be a positive, so I either need a positive 1 and positive 7, or a negative 1, negative 7. I need to add up to be positive 3. None of those do that. So you can't factor. So no more rational roots. no more, but I did have 1. So my rational roots are just x equals -2. Notice, it is not plus or minus 2. It is just -2, because only -2 worked. All right? Positive 2 is not a rational root, so it's only x equals -2. Last problem. So we have the factors of 4 are 1, 2, and 4. But the factors of 1 are just 1. So once again, this is kind of nice. It is the 1 divided by all of these things. So your possible rational roots are 1 divided by 1, which is 1. 1 divided by 2, which is 1/2. And a 1 divided by 4, which is 1/4. All of them with a plus or minus sign. Right? So then I'm going to check each to start with until I find 1. So 4, and I'm going to plug in a positive 1 to the third, minus 7, plugging in a positive 1 squared, plus 2 times 1, plus 1. Hey, and I do get 0. Nice. Okay. So that means 1 is a rational root. So then I'm going to do my synthetic division. My coefficients are 4, -7, 2, and 1. Once again, I'm not missing anything. I have a 3, a 2, and a 1, and a 0. Bring down your first one. 1 times 4 is 4. -7 plus 4 is -3. Notice that's -3, not positive. 1 times -3 is -3. 2 minus 3 is -1. And 1 times -1 is -1, which then those cancel, which they're supposed to because 1 was a rational root. So this now becomes 4x squared minus 3x minus 1. I am quadratic, so I can go ahead and try and factor this now. So 4 times -1 is -4. Oh, I'm going to time out real quick, and I'm going to fix myself. These are supposed to be n's. I'm going to change those. That is important. Those are supposed to be n's. Okay, let's continue. So I need two numbers that multiply to be -4 and add to be a -3. If I am multiplying to be a negative, I need one positive and one negative. So when I factor this, I'm going to have n, and I'm going to have a positive and a negative. My two numbers would be -4 and +1, because 1 times -4 is -4, and 1 minus 4 is -3. But I'm not done factoring. Remember, you then take both of those, and you are going to divide both of those by 4. And you are going to divide or reduce and then slide if there's still a fraction. So 1/4 cannot divide, 1/4 cannot reduce, so you slide your 4 in front, so 4n plus 1. And then this one would become n minus 1. Remember, this is equal to 0. Since both of those are linear, we would set both of them equal to 0. When I solve this first one, I'm going to subtract your 1 and divide by your coefficient of 4. And your other one, just flip your sign, becomes a +1. So here is a rational root. So n equals -1/4, +1, and +1, which I already had, so I don't need to write it again. There you go. Those are your only rational roots. -1/4 and +1. So notice it is not plus or minus +/-1/4 anymore. That was only like that because it's telling you that there are two possibilities. Maybe it's one of them, maybe it's both of them, maybe it's neither of them. In this case, it is just the -1/4 and just the +1.